Immunology Insights, Basics and Beyond, Chapter 23, Louis Pasteur and the Germ Theory. Marcello here. Welcome back to Immunology Insights, Basics and Beyond. In our previous chapter, we explored the immunological memory, the incredible ability of the immune system to recognize and respond more efficiently to previously encountered pathogens. But how did we first discover that infectious diseases were caused by microorganisms? The answer lies in the groundbreaking work of Louis Pasteur and his germ theory. Today, we will dive into the life and contributions of Louis Pasteur, whose pioneering work laid the foundation for microbiology, immunology, and modern medicine. So let's talk science. Who was Louis Pasteur? Well, Louis Pasteur lived from 1822 to 1895 and was a French chemist and microbiologist who revolutionized the fields of infectious diseases, vaccination, and food safety. His research fundamentally changed our understanding of how diseases spread and how the immune system can be harnessed to prevent infections. Despite not being a physician, Pasteur's scientific curiosity and innovative experiments led to breakthroughs that continue to save lives even today. His contributions to immunology are particularly remarkable and include developing some of the first effective vaccines. Now, let's come to his germ theory. Before Pasteur's time, many scientists and physicians believed in spontaneous generation, the idea that living organisms could arise from non-living matter. Pasteur disproved this theory through a series of meticulous experiments, demonstrating that microorganisms were responsible for disease and decay. His famous swan neck flask experiment showed that when sterile broth was exposed to air but protected from dust and microbes, it remained uncontaminated. This provided definitive proof that microbes did not spontaneously appear but were instead introduced from the environment. This led Pasteur to contribute to the evolution of vaccination. The idea of vaccination did not start with Pasteur. Edward Jenner, as we learned in a previous chapter, had already introduced the first vaccine in 1796, using cowpox to immunize against smallpox. Jenner's method relied on natural cross-immunity, where exposure to a harmless pathogen provided protection against a related deadly disease. Building on this concept, Pasteur pioneered a scientific approach to vaccine development by deliberately weakening or attenuating pathogens, allowing the immune system to recognize them without causing the disease. His work provided a systematic and reproducible way to develop vaccines, setting the foundation for modern immunology. With that, Pasteur heavily contributed to vaccination. His key vaccines include: first, the rabies vaccine. Pasteur developed the first rabies vaccine using an inactivated virus. His most famous case was Joseph Meister, a young boy bitten by a rabid dog, who survived after receiving the vaccine in 1885. This success validated post-exposure immunization, a principle still used today. Second, the anthrax vaccine. By weakening Bacillus anthracis through heat exposure, Pasteur demonstrated that livestock could be protected from anthrax, proving that immunity could be induced artificially. And third, the chicken cholera vaccine. A fortunate accident led to the discovery that weakened bacteria could provide protection without causing the disease. This marked the beginning of a systemic attenuation technique which are still used in modern vaccine development. In brief, Louis Pasteur discovered the chicken cholera vaccine by accident in 1879 when he used an old, weakened culture of the bacteria Pasteurella multocida to infect chickens. Surprisingly, the chickens didn't get sick. Later, when exposed to a fresh, infectious culture, they remained healthy, revealing that the weakened strain had immunized them, leading to the development of the first attenuated vaccine. Pasteur also had a great influence on medical microbiology. His work inspired Robert Koch who later identified the causative agents of tuberculosis and cholera, further solidifying the germ theory of disease. His discovery set the stage for modern microbiology and infectious disease control. Pasteur's work still greatly matters today. Louis Pasteur's discoveries laid the groundwork for modern vaccination programs, infection control, and public health measures. His work not only saved millions of lives but also paved the way for future immunological research. Without Pasteur, our understanding of immunity, disease prevention, and microbiology would be vastly different. His impact extends beyond science, influencing how we combat infectious diseases to this day. To conclude, Louis Pasteur's work fundamentally changed medicine and immunology. By expanding on Edward Jenner's early vaccination efforts, he established the principles of modern vaccine development, proving that science can save lives. In the next chapter, we will explore even deeper the history of vaccines, tracing their origins from early immunization practices to sophisticated technologies used today. Before closing, I have a small request. If you enjoyed my content and want to hear more, like and subscribe. It's a small step for you, but it helps me a lot. So see you next time and thank you for listening.